We are recording. Good evening, everybody. Today we jump into the new module. We're in module 2 now. Congratulations. Module 1 is done. Module 2 is much shorter. We'll get through this a lot quicker. Week 9 is SQL and Pi. I don't know how you're supposed to say it. That's an ORM of sorts, and an ugly one at that. But it's a good one to learn. We'll talk about my favorite later, I'm sure. I believe we already went through these slides, or you guys have gone through these slides, right? Am I wrong? You went through the SQL querying language. You've seen these slides? No?
Yes, I think we had them on Saturday.
I thought they were different ones. I don't remember seeing the relational database stuff.
Like, I think they were in the lesson, but we didn't actually go through them.
Okay. So we've got two things here, and I guess I'll run through them both. The thing is, the lecture runs it runs along with this. I think we'll blast through the slides and then kind of walk through the lesson a little slower, or just get it done. The thing is, it's not a very interactive lesson, so I'm kind of just showing you, and if you have questions, we're going to answer them with my really strong SQL skills and tons of experience in it. So here's the intro. Two major types of databases. This is what we're going to be using in class, but you need to know that these exist. I like relational databases because that makes sense to my brain. Basically, different tables are going to relate to other tables based off a key. Easy to, you just have to know what the key is. And a lot of the times you don't even have to know what the key is. You can abstract that out with, your code to figure that out on its own. It looks like a lot to keep track of, but it's really not. And the more you kind of dig into this, the more it, I guess, makes sense. The two halves of RBDBM's relational database modules. I don't know what M stands for. I'm guessing modules. That's probably not right. Storage mechanism, tables, columns and rows, easy peasy. A table is a things like a students or dogs. Columns are going to be like name, ID, favorite color. Rows are going to be, Jordan, ID1, blue, and so like your rows are the data. Coming out of OOP, this kind of you can kind of relate it to that. Think of a table as kind of like the class. The column is going to kind of like be your instance variables, and this is going to be the actual instance of the object, if you want to think about it that way. Query mechanism, we'll be using SQL. SQL's been around for a while. It's tried and true. It's fast. It's kind of duck typed. You can kind of read SQL even if you don't know how SQL works, just by kind of reading through it. It's not a complicated language to learn, and it's very powerful, and people make entire jobs out of it. We are going to get familiar with it, and then you're going to have ORMs do a lot of this for you, but nonetheless, you almost always are going to find yourself digging into a database. Sometimes there's a disconnect. Sometimes something's not. You just really want to make sure something got into the database, or you've borked your database and you really need to get in there and kind of finagle with it. That's when you're going to have to, lean back on your old SQL tools, which you can always Google them, but it's nice to know what you can and cannot do with the database. Yep. Next slide. As I said, table, the whole shebang. Column, the variables. Technically, this is just the column, but this is all the IDs, and then rows are going to be the individual instances. Schema is defined as a representation of the plan. A schema is not your database. A schema doesn't have any data in it. A schema is basically a reflection of how your database is set up. Data inside the database generally doesn't come with a schema. That's called seeding. So the schema probably shouldn't be doing any seeding or inputting or injecting anything into the database. It should really just be the initial plan for the database, And any migrations or changes to the database, they'll be loaded up into the schema as well. This is something you can either create on your own or it could be automated through, various libraries. Yep. It's got these three things. Other parts of the schema include whether or not columns have null values, not null foreign keys, indexes. More or less, it's going to be kind of the rules for your database, the rules for the lower columns and rows. Tables are identified by name, create table students, create table addresses. You can call them whatever you want. I have a really bad habit of making them singular, and that's just the way I like to do it. But I think it's more correct because I've been corrected many times. No, your tables should be multiple names. Just for me in my brain, I think of them like classes, which maybe I shouldn't do, but keep yours plural. Keep them lowercase. It's also a very good practice to include a unique integer column named ID. Yeah, you better have IDs in your data tables. You need them. In fact, most ORMs do them for you, and there's a lot of good ways to make it for you. Table name examples: persons, purchase orders, likes. These are all good things. They're all plural. They're all lowercase. Column. Each column has a name. Lowercase. Singular nouns or adjectives are a good naming convention, because a person doesn't have names. They have, or rather first names. They have first name, last name. These should be single things. If they were to have multiple, that would be, a different thing. That's going to be, what is that? That's when you, oh man, my brain just quit. Basically, you can have it's one to many relationship. So if we did have, we'll get to that. I don't know why I'm jumping ahead, but basically, these would be singular in all cases unless it was a one-to-many relationship, whereas the students, or rather, we go to something that there is only one of. I'm trying to think of a good way to do this. Basically, for each one of these students, a single student could have like different classes, as in like school classes, and those would be their own data table, and you could link them to each instance through a foreign key. And then that would be the students' classes, and those individually would reach out to a bunch of different things. But maybe I should stay on. I'll stay on script. Column types. Each column type has a type which determines what kind of data it can hold. ID should be an integer. This will only accept integers. If you try to pass it something else, it won't like that. Varchar 255. This is a variable characters 255. It can accept 255 characters, no more. It'll stop you. 255 is, I don't know if that's the limit for varchar or if that's the common normal max we go to. It might tell you no if you go more than that. If you want more than 255 characters, we have answers for that as well, and we'll get into that. You can also set Boolean. There are a lot of constraints you can set on your database. Truly and honestly, these things can be handled either by the front end or the back end, but you don't want a bug that injects something bad in your database. So make sure the database has rules, because injecting bad data into it can be a real pain to go track down. You'll actually have to use your SQL skills if you do that. Yep, here are some more that I was going to talk about. So column types depend on database system. These are some common ones, though. I believe these are probably in all of these different types of databases. Integers, easy. Decimal, fraction number, or float. Varchar, we talked about. Text. Text, you can make it as long as you want, as long as it's in 16 kilobytes. You can also do, I believe, medium text and large text, which get larger. The reason you don't want to do that all the time is it takes a lot more space. Varchar allocates memory for that much space. Text allocates a lot of memory based off that much text. So your database is going to get real fat, real quick. So don't use text unless you really need it. Most of the time, if you're saving things that are like massive, you know, amounts of text, if you're really going over 255 and you really feel like you need to save it, maybe save it somewhere else, right? That's when you would consider, like if you're trying to save like a multi-page document, maybe you just save that document in your repo or app, or host it somewhere and reference it from there. Date, timestamp, my two favorite things to play with when I'm doing database stuff. It's always a pain. But y'all find that out, I guess. It doesn't have to be a pain, but often formatting date is probably one of the most painful things you will ever have to do. That is a very simple thing that you have. It's one of the most painful common things you got to deal with. Schema modifications. As you maintain software, it's expected that you will create new classes, write new methods, and refactor existing code. Your database is going to have to change with that. New features come with new tables, columns, perhaps migrating existing data. Yeah, you can also modify existing columns. Changing a database schema often isn't cheap. Yeah, so it can require a lot of coordination. You do have to think ahead about what you're doing. A lot of times you have to really consider every, I guess, edge case for before you make a change to your database that you've always got created, because it's it can be hairy and you need to document it, and you want to keep all these migrations going forward and keep track of when things were changed and why they're all there. Best bet, do the absolute best you can when you're creating a database. It's not, it might feel wasteful to have a bunch of columns that you don't need, but migrations are scary, and building it with there's no data on it before there's any requirements for it is not scary. But yeah, but don't be afraid of making changes to a database. It's not that big a deal. Successful software is built from a small module that does one thing well. As I kind of talking about, this is a plan for edge cases with your code. Single responsibility. The same adage applies to storing data in an RDBMS. Large tables that store more than one record or model should be broken up into multiple tables. Yeah, do it when you can. For instance, if you've got a bunch of addresses for these people, maybe you don't want those attached to these people. Maybe you can make its own database. Now, I don't know if that's the best example, because very likely, depending, I feel like most of the time people are going to have this different address. These are almost always going to be unique addresses. But it really comes down to how you want to structure things. It is right. The smaller the database, the smaller the table, the easier it is to kind of keep track of where things are and split those up. But if you do break things up, don't repeat yourself. So if you got smart and decided, oh, I'm going to break up, my students and my addresses, and then you put these keys in here that are not linked. Let's say somebody changes their last name, and you're like, oh, okay, we got it. We fixed it in students. And now somewhere you got a bug in your code because you never went to this other database and fixed this. The same reason you keep your code dry. It's easier to maintain. It's less to think about. Oh, I guess I was supposed to ask you all that question, but yeah, that's why. Don't duplicate information, and it's wasteful. Now, what is an alternative to this schema? What do y'all want to do with this? What would you do instead?
Just make the name a foreign key in the address one.
Yeah, or make the student a foreign key. Bam. Or the address and ID. Yeah, you're right. So it's got an ID. All we do is slap an address ID over here. Real chunky method of doing this. Could be automated, but yeah, it's got these unique keys. These keys belong to these never repeated. So that's an easy way to do it. Data integrity. Good schema is important. As I talked about a little bit earlier, you can do a lot of constraints on the front end, on the back end, but the database needs to have its rules also. I would say it's probably the most important place to have it. And think about things like this, Not too likely people are going to have duplicate emails, but it is possible. So on, where it matters, make sure they're not, make sure things are unique, make sure things, data comes in the way you'd expect it to. If you're asking for like a phone number, don't give them varchar 255. They don't need that. And they could inject something like, drop tables star or something into your phone number where you don't want stuff like that. But don't be too restrictive and bite yourself later. Don't make like first names unique. That would be stupid. And probably run into trouble real quick with that one. In SQL, all commands are lumped together and called queries, including commands that don't necessarily query for anything, but instead do something. Yep. So just because you're not querying for info, we still call them queries. Create table is an example of a query. Most often you're going to be using these. Generally, I want to go look at stuff. I want to insert something new. I need to update existing, or I just want to straight up delete a row. Easy peasy. There's a lot more queries than this, but these are your common ones. Select is the most common. And if you don't read SQL at all, I mean, you can probably read this though. This is not complicated. Select star, which pretty much always means everything from students. Well, we can guess what that's probably doing. It's going to list all of the students. You do have to have a semicolon at the end of all your commands. These don't have to be capitalized. This is just conventional. You capitalize your queries so it's easier to read, easier to see that, or rather that is the convention. But if you do select lowercase, uppercase, lowercase, uppercase, lowercase, it'll probably still work, or go all lowercase. Instead of star, you can select individual ones like this, and it would list just those two. Easy peasy. Often you'll want to retrieve records where they only match condition. That's where we get into where. Where is also, what was where not up there? Yeah, where's a popular one? Select ID. I want the ID and I want the first name from the students, but only when their ID is equal to 2. Should only bring you the 1. That makes sense to me. Where has a lot of conditionals. You can use any and all of these. These slides are going to be useful for you during your challenges and going forward. So feel free to come back and reference these, but it works a lot like, I guess one thing that getting into coding is going to annoy you off the bat is we use single equals to do equal to in SQL. So just remember that double equals will fail. Here are some examples. Wait, what's that one mean again? Column is not equal to a value. Oh, okay. So that's like bang equals. Yep. So first name, Andre, that makes sense. Where the grade is not an A. So it's going to be everyone who didn't get an A. Select from classes where credits between 3 and 4. Probably going to be everything between a 3.0 and a 4.0. Select star from enrollments where grade is in this range, right? A and B. So everyone who's got an A and a B. Select star from classes where name, like, art, and credits greater than 3. I think this would have to be, I think this is a variable, isn't it? I didn't see this when I went through the slide last. I think this is a schema variable that they've already associated with something. We'll get into that. Don't freak out about that just yet. Insert is how you insert rows. This is how you do it. You insert students, or sorry, insert into students. You list what you want to put in there, and then you list the values. Easy peasy. This is what your seed files will kind of look like. A bunch of this. Update. Update allows you to change values with a column. Makes sense. Update addresses. Also, multi-lines, totally fine. You could do a million, in a row, or you can break it out. I believe you can even use tabs. It doesn't matter. SQL is going to read left to right and keep jumping lines until it hits this semicolon here. So feel free to break it up a lot like JavaScript. It doesn't care about tabs. It doesn't care about line breaks. It's just going to read it. So you're going to update addresses, set, and line 1. You're going to change line 1 to your address. I guess line 1 is the address column. Zip code here. So Makes sense. And it's only going to change it for the ID that is equal to 2. Delete from addresses where ID equals 2. We can probably guess what that one does. Update and delete without conditions. So I was playing with this, and my computer was stopping me from doing this. But I'm going to read it because it is in the curriculum. Caution, if you fail to include a where condition, you'll affect all rows in a table. So update address, set line 1 equals 200, blah, blah, blah. This is telling me that that's going to update every single line 1 and zip code in the entire addresses table. And maybe it will do that. When I was playing with pSQL, it was telling me that wasn't valid. But always include your where. This is telling me it's going to delete all addresses. I also think this would fail, but I could be wrong. I'm going to play with it a little more after this. I don't want to disagree with the curriculum, but don't be surprised if your database doesn't let you do really terrible things. They tend to try and stop you from doing queries like that. They want a star if you're gonna do something like that. Great. Any questions about these slides? You can hold on to them because we're about to kind of run through it again with the lecture materials. But I'm happy to answer any questions right now.
Yes, what is ORM?
Operational. Goodness, I looked this up because I was like, they're going to ask me what an ORM is. It's object relational mapping, I'm pretty sure, but just let me double check that. Object relational mapping. Basically, there's a lot of reasons for it. I would say the biggest reason people will say they exist is actually not really the reason. And they'll say, so you don't have to, put raw SQL into your code. That's not so much a problem. I think the real reason an ORM is, really important is because you can map it to multiple. An ORM is what goes in between your back end, or if somehow your front end should be writing to the database, but maybe as long as your app will be writing to the database. You could either be doing that with SQL. If somebody they fill out a form, you could have it in your code to say, hey, insert into table, do this. Or you can use an ORM, which is going to be a separate library. It could be a Pythonic library. And by Pythonic, I just mean it looks like Python. And we'll be talking about that with PsycOpG, which is supposed to be a little bit easier to read than SQL. It tends to be more clean because you don't really want to put, if you're putting SQL into your code, SQL doesn't go into Python. SQL is not Python, so you have to write it in string version. So you'll be writing a string version of the SQL query you want, and then running that against your database, which is kind of icky. That's not a good example, or that's not a good reason, but you don't really want raw SQL laying around in your app. So you can use an ORM that says, hey, you go talk to SQL. I'm going to tell you, update this table, do it this way. And I'm kind of going to act like it's a dictionary with this library, and then you go figure it out. And the ORM will say, okay, this is a dictionary object. I can rip that open. Okay, where does it want? I can figure out where that goes on the table. So it takes the SQL out of it. So you don't need to learn SQL when you've got an ORM. The other reason, and the main reason, is if your development or prod or even testing databases are different types, which can happen, or if you're developing an app that could be used on a multitude of different databases, an ORM only needs to know what kind of database it is, and that's all you have to focus on it. So you can tell the ORM, hey, this is for a MySQL database. I don't care. I don't want to learn MySQL. I'm going to run my backend exactly the same, whether it's on Oracle or MySQL or MongoDB or pSQL or SQLite. Like, it's going to handle the conversion for you. So it's really a good, there's a lot of good reasons that you want to use an ORM. The reasons that you need to learn SQL or want to learn SQL is if that's not really an option, right? Sometimes you're dealing with databases that are like tens of millions of tables, or not tables, but columns, but maybe it could be tables. They get massive, right? And you can have people writing these absurdly long queries, and getting that done, it really comes down to time and like efficiency. And raw SQL is always going to be more efficient than Python or some Python, ORM, because it has to convert, it has to do its own thing, and it's going to take longer. SQL's quick, it's fast, it's good, but it has its purpose, and its purpose is usually not in your application. My favorite is Peewee. I love Peewee. That's it's a really, really good Python ORM. It looks just like you write in dictionaries. I'd highly recommend it, or at least take a look at it at some point. Because I don't like SQL Alchemy, or what is it, Psychopgy?
How do you
This one.
spell Peewee?
Peewee. There's a really good post from the
Thank
there's a
you.
really good post from the guy who he's like, hey, I wrote Peewee, ask here, ask me anything, or like these are the things I do and don't like, or these are the advantages and disadvantages. And at the very end of the disadvantages, he wrote, it's called Peewee. It's a dumb name, obviously. SQL Basics. This runs really along with the slides we went through with some new things. So we're going to kind of run through it just again. Now that you've got a schema and created some sample data, y'all did that on Saturday, right? Or whenever. Right, cool. Use these things. Select queries, inserts data into a row, update changes of column values, delete, deletes, whatever you tell it to delete. You'll be executing queries against your school database, so make sure that's available and seeded with the same sample data from the previous challenge. I'll fix that. I was having a hard time loading up this, so I'm not be able to do this in real time in front of you guys. But that's all right, because it's going to be exactly the same. You use the most simple version of select, which is this one, star, gets them all. This returns all the rows and columns from a particular table. A bit risky. Yep, if our table held millions of records, we would never want to do this ever. And yeah, you could overload the server, which is definitely another thing to think about, which I've never had to worry about. But yeah, you can overload your database server pretty easily by just slamming it with queries, or giving it really, really long queries that take a long runtime, or have it running back over data. So instead, you do something like this, select column 1, 2, 3 from the table. In this case, we would do something like select ID, first name, last name from table. Querying just these columns might be the query you'd be using when building an autocomplete feature. You wouldn't need any of the other columns. So yeah, sometimes you don't want all the data, and if you don't, you can ask for them specifically, is all that's saying. Aggregate functions. Besides selecting particular columns, you can select aggregate values, computing from the raw values in the table. Common use aggregate functions like min, max, count, sum, and average. These you'll get some use of in the coming assignments, which I think they're pretty fun. I think SQL queries are kind of fun to play with for a bit. And I'm not trying to tell any of y'all that this is something that we're going to learn it. Don't worry about it again. Like it is a cool thing, and if you really do dig into SQL and get good at it, you can become one of those people at the company that just is known as the SQL person, to be really good at it. It's a good skill to learn, and you should all definitely pay attention to it. Here's an example of find the worst grade from the enrollments table. School, select max grade from enrollments. That makes sense, right? It's going to return the highest number, which would be the latest character in the alphabet, or probably the highest number, depending on how you're doing that. Where conditions. We've talked about where conditions. You can find a student record by the ID. You could list all the students under a particular course. Finding the number of students whose birthday is in the next month. All things you can do with where. Where is very popular. So select star from table where column operator value, just like we're kind of used to, where, birthday equals, I don't know how you want to do next month, but you can figure that out. These are possible operators. We've seen these. When a single operator isn't enough, you combine and or. Also super useful. Select from classes where name like art and credits. Oh, I know what this is now. Yeah, that's a table. I think it's annotating a table, isn't it? So select from the classes where name is like art. Where is this? No, that's a wild card, isn't it? I'd have to look at the tables, but I assume you have art classes of like art 1, art 2. So this would look for anything that starts with art and ends with whatever, and credits greater than 3. Or credits greater than 3. Easy peasy. Sorry about that. I was thinking this was a variable, and that's a different thing. No, that's a wild card. Ordering your query results is easy by order by. Yeah, extremely easy. Don't forget order by. I've seen people really struggle with their SQL queries. Use order by and it puts them in order for you. Select star from classes where credits greater than 3. Order by name descending or ascending. So this should start at the highest number and go down, lowest number and go up. And now joins. Probably the biggest scratch your head thing that you're going to do in SQL. I did mention to Sean that this is something we are going to sort of touch on and you're going to really need for the assignment tomorrow. So if you have a lot of questions about joins, Sean should be getting ready for those. I'll answer as best I can. Because again, they get a little sloppy. Up until now, you've only selected records from a single table at a time. Now it's time to really up your SQL game and learn how to join multiple tables together with a single query, which is something you'll commonly need to do. SQL joins come in a number of flavors. For now, we'll just be doing inner join. There's also outer join. There's also like left and right join. A join can allow us to support a pretty common use case, retrieve students and their addresses in a single query. Remember, we broke up students and addresses. So select from students, inner join, addresses on students.addresses underscore ID is equal to addresses.id. So this is saying, I want to see all the students, but I want to see everything from students, but I want you to join on addresses where the address is equal to students.addresses here. I want the rest of the address and stuff. So this is almost like saying select star from students and then select star from addresses and line them up for me. So we're going to have the student here. It gets to the address ID, and then it starts telling us about the addresses. Does that make sense?
Can you repeat it one more time? Sorry.
Yep. Select star. So get me everything from students. Give me all the students, and I want all their data. And then I want you to inner join. So this is done. Ignore this. So this is already ran. Well, I don't know if that's how it really works, but mentally you can think about it. All right, we get all the students. Check. Now I want you to do an inner join. And what I want you to do is I want you to join the addresses. So give me all the students, and then I want the addresses, which is a different table. And obviously, I want you to line them up. So what you're going to line them up on is where student, it doesn't say where, but think about where students.address ID is equal to the addresses ID. So students have this column here called address ID, 1, 2, 3, 4. And those align with the addresses table. And these IDs should be the same because we know, when we created this address, we set it, we gave it this ID and we created the student. We said, hey, that's from that one we made, right? That's primary key. That's your new foreign key. So this is the condition. This is what you want from the first table. This is the table you're attaching to it. It is a lot less duck type than everything else we talked about. And it's okay to be a little confused by the syntax of it, but don't worry too much. For joins, they pretty much all are going to look like this for now.
Does that only work if they're relational databases?
I
'Cause
don't think that,
Because I mean, like the second database wouldn't have. I guess it would have addresses.id. Never mind.
as long as there's IDs, you can reference them. All you're doing, it doesn't even, these don't even have to be relational. They could be, or sorry, these could have like be linked to each other, but in this case, it doesn't matter if they are or aren't. All we know is that students have an ID called address ID, and IDs have an ID. And we're saying, without knowing really about how they're formatted, I want you to attach them where these two things are the same. So in a non-relational database, I imagine this query would work as well because they both have IDs. Oh, does this break it down for me? We'll see if this is better than how I described it. Columns to select, starting table, join type, join table, how to join the tables. Yeah, maybe I should have just showed you this. My description wasn't as good. Wasn't as obvious. The last clause can sometimes be difficult. We need to explain to the database how we want to connect different rows from each table. In this example, we connect each student row with a single row of the address table by matching them with their IDs. You might think of on in a join as meaning when. Yeah, when or where, whatever you prefer. Did you notice anything unusual? For one, this query returns two columns named ID. One is from the students table, the other is from the addresses table. Plus, we also have the address ID column in the students table, which we don't really care about. We know they're matching. We told it to. They wouldn't be there together if they weren't matched. So instead of the star, maybe we do something like this. Select students.id, students.first name, students.last name, birthday, address ID, blah, 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 blah. Get it all from students, inner join addresses, just like we did before. So this is going to kind of give us everything, but it's omitting out the ID of address. Yeah. Oh, okay. Hold on. I moved too fast. We're picking specific things from students and specific things from addresses. Oh my goodness. All right. Select. All right. I gotta back up. You're gonna select a few things from the students. So ID, first name, last name, birthday, address ID. Then you want these values. So select addresses, line 1, city. That's probably a mistake. State, addresses, zip code. From students, inner join, addresses on. So this is all the same. So basically, this is all the same as up there. The only difference is we replace the star with these specific things. You can, you would assume that you can get ID and first name and last name because we're taking this from students. But because we are doing an inner join, you can still reference address IDs or address values up here, address columns from here. That's a lot of things to query. I would just star it at that point, but we omitted one ID out. Yeah,
I have a quick
all that
question.
work to cut this out or this column. Yes, what's up?
Maybe I just have a poor idea of what foreign keys are, but since I kind of thought foreign keys need to be established because of the joins, but maybe you could explain what foreign keys are. So better.
No, they don't. They joins will work without a join. Has nothing to do with the way you set up your database. A foreign key, if we made a foreign key out of addresses, and I don't know if we should be talking about foreign keys yet, but I will talk about them. When we were creating these students, we could make a foreign key. We can make one of our columns a foreign key. Is the word here? All right. I don't know if I want to get too into that, but basically the way a foreign key would be, you're going to say, hey, this is a student. Students have a first name and last name and their address. And you're going to say, oh, first name is a varchar 255, last name varchar 255. Address is a foreign key to the address table. What that would allow you to do is whenever you create an address, it requires a primary key from the student. So an address cannot be made. And when you go to make sorry, am I doing that right? Sorry, you wouldn't be able to create a student without an address to give them. So you'd already need an instance of an address for them to go pick from. So you wouldn't have to do a join for those. If you had set them up with a foreign key, you could just add, or rather, it would be something like, I lost my spot. You wouldn't need to join. You could do all of this without the join, without the addresses. You could take this out. Addresses.zip code would actually be students.addresses.zip code. Because it's got foreign key called address. It'd probably be called address in that case. But it'd probably be called students.address.zip code because the student knows what its address is because it is foreign keyed to it. What we're doing is we've decided, hey, these always match up. These two always match up no matter what. And why I called it sloppy earlier, because you would use a foreign key for that probably. You don't have to, but that's the way I would do it. But because we're not using a foreign key, because we're deciding when we create these address, when we create the student, they're both going to get a number and that's going to be unique to them. We have to use a join to get them to squish together with a query. It would change our query a lot if we had a foreign key. It would be very similar to a key value pair on a dictionary or something. You would think JavaScript, you know, because you can run dot methods. If you had an object called student with a object called address, and the address had a value, you'd go student.address.id, or sorry, student.address.line1. If you had an object within the object, if your value was another object. Does that make sense, or did I make that more complicated than it needed to be?
I'm still trying to wrap my head around it, but that helped a lot because I knew it had to do with something with sharing between the tables. I just hadn't done enough reading on my own yet to kind of iron it out. Thank you.
No problem. Yeah, I need to pull up Miro. Miro would be good. I just want to draw and show you what because it gets a little complicated. But don't worry, foreign keys come later, and we're gonna move slow with this, and you're gonna do so many SQL queries. They hand you a lot here, so you're gonna get a lot of practice.
Okay. Yeah, we kind of touched on it with the schemas on Saturday, I believe. It was just a quick edit though.
It will make sense. Especially if you have something that helps you visualize your database. But this is a whole new thing. We've been learning coding, now we're learning database. This is a completely different, mindset. And why y'all be so much more valuable than every other coder, because you're gonna know about everything. You're gonna be real full stack, actual full stack. But not actually, because you're not gonna be super good at all of it, but you will know everything. You at least heard of it before. Cool. We prefixed each column we select with its table name. That's why there's an ambiguity when executing the query. Yeah, there's no ambiguity here. We're telling it exactly what we want. Notice anything else strange about our results? How many student records should there be? Check your students table. 5, right? We didn't see Leopold Town in our results when we joined the addresses table. It's because of how inner join works. Here's a summary of the different join types. What's going on? Inner returns rows that have a match in both tables. Left returns all rows from the left table matching the right. Right, other way around. Full returns matching rows from left or right table. Leopold Town, oh, okay, I assume because he didn't have an address ID. That makes sense, right? We would not have expected to see him there if he didn't have an address ID. Easy peasy. Changing the query to return all the students and any matching addresses. All right, so this is going to get all the students and any matching addresses from left join addresses on. So this is saying left join, meaning we want all the students and we want these values from them. It's on the left. This new table that we're bringing on the right, addresses, just slap it on there as best you can. So now the query looks like this. It's the same, but now we have Leopold Town, blank address ID, blank, blank, blank. This is all blank, but at least he's still showing here. Had we done a right join, I don't think we would have gotten the students. I think we would have gotten all addresses and not students along with it. Where and join can be combined. We'll query for students who live in Maryland, returning the student's name, city, and state. Select student ID, first name, last name, address, city, state from students. Enter join addresses on student address ID equals address ID, where addresses.state equals Maryland. This is a big long query, but we're just adding one piece at a time. We selected the things we want to see from both of the tables. We're interjoining where they fit, put them together. If there's something missing, it doesn't get to come along. And then we only want to see the ones in Maryland. Apparently we just have the one here. That adds an extra layer, but I don't think that adds any extra complexity. You can further, specify your query with where. Insert. So far, we've just been reading. We can insert with insert. The most explicit insert query looks like this. It's possible to forego the list of columns if you're going to set a value for every single column in the table. But with that approach, you'll need to supply the values in the same order as they appear in the table schema. You won't be able to rely on having the database auto-generate fields like ID, since you're required to supply values. So basically, you can pass them in as args, I believe. But I wouldn't do that with a database. You can do that with your code. Don't do that with a database. Don't insert things like all willy-nilly. Let's make sure we set line 1 is equal to this, city is equal to this, state is equal to this. You could probably get away with not doing any of these equals. But if you get one of these out of order, it's now in your database and maybe you borked it. You can set new values for as many columns as you'd like. Yep. Oh, sorry. This is an insert. This is an update. Make sure you run your insert query with equals. Sorry. Like we're doing it with this update. Update wouldn't work. But update, we're changing rows. So update addresses. Yeah, basically, we're making an update to addresses. We're doing it to the student who hasn't, or sorry, we're doing it to the address that is line or has an ID of 2. These are the changes I want. I want you to make it look exactly like this. So change any or all. You can change them all if you want. You can change just one of them if you'd like. As long as you have spaces in between before your next query or your next semicolon, it'll work just like this. Throat's getting tired. It's a long, lot of reading. While our example included a condition that ensured we only update a single record where address is 2, update queries can update multiple rows at the same time. You can eliminate the condition entirely. So I guess update does work if you do it this way. Update enrollment, set grade to A. Everybody's got an A. Delete. Delete queries written just like update queries affecting all rows that match a condition. So you can delete the address of the ID is equal to 2. That was a lot, but we went over it twice, kinda, and you've done some of this before. Does anyone have any questions about what I've gone over now?
So update does the value of the column, but if you want to change the column,
If you want to change the column,
I think is that alter or is it modify? Because different.
yeah, I think it's alter. I think I misspoke before, but I'm pretty sure it is alter.
Okay. And then once you join the tables, two tables, and you want to search that particular table that doesn't have a name, so you always have to start with everything,
Yeah.
you go through it, and join it, and then you put your condition every single time.
Yeah, so we won't get into this yet, but you can set a variable. But again, you're just joining for this query, right? You're not affecting the database at all when you're doing a select. It's
Okay.
just I want all these things. You're not writing to the database. You're not creating a new table. You're not doing anything other than give me all of this information, and now I'm going to where and join and whatever and do that. But you've pulled it. You're not affecting the database. You can do
Okay,
things.
so it doesn't create a new table. Okay.
Right. No. Yeah. No, that does not create a new table. The only way to create a new table is to use create table.
Yeah.
Something you can do, which you'll get into, maybe you can say, hey, select these, join these. These are now, treat these as, I think it's as, I need to verify that, but I'm pretty sure you can say select this and enter join as new variable, and then you can say from this variable do that, but that gets a little complicated, and you're re-multi-lining at that point.
Okay.
Here are your challenges. We have schema modifications and we have SQL queries. You can do them in whichever order you see fit. Also, I guess this is technically required reading. Is this just this again? Why is this here? Oh, okay, that's weird. Yeah, feel free to use these names are wrong. Oh goodness. So this is what I just showed you. It's called SQL queries here, but we changed it to SQL basics. That's fine. Feel free to use the slides or the lesson to work on your challenges. You'll almost certainly need to reference them, and that's okay. But that's it for the lecture. If we don't have any more questions related to the lecture, I'll let you guys get started. All right.